You're all now accomplished programmers, and you're going to go out into the world. In fact, half of you aren't even in class today, apparently, as a result of that. So you're all going to go out into the world and do amazing things, and I hope you do. But before you do that, I have one last job, which is to scare the shit out of you. Okay? And that is my plan for today. So last week, there was a very interesting problem that was reported in the press. Malicious code found in NPM package event stream downloaded 8 million times in the past 2.5 months. Now, what is NPM? You've all heard of JavaScript. It's a programming language. Node, apparently somebody decided it's not bad enough that it causes problems on the web. We should also bring all of those problems into the desktop. So NPM is the ability to write JavaScript programs on your desktop. Okay? And so you can write servers and things like that in JavaScript. It's not a bad idea. It's you know, there's good and bad side to it. And there are large repositories of libraries, of useful libraries, and that's essentially what NPM is. NPM stands for the Node Package Manager. So you can bring in packages that other people have written on the internet, bring them into your system and make use of them. Okay? That's what NPM is. Well, except apparently there's this package called Event Stream that's downloaded by a lot of people using a lot of different systems, and there's some malicious code in it. Okay? And it says the Event Stream package makes working with streams easy. I thought that was a good link to our course. So people apparently want to do programming with streams quite a bit in JavaScript. It's not built into JavaScript. And so this thing makes it easy. It's getting roughly 2 million downloads a week, etc., etc., etc. Okay? And there's several analyses of these on the web, of this on the web. This is from the official NPM blog. And what they say is the injected code targets this application called Copay. Now the good news, I'm not going to go into details of exactly how the attack works. It's quite sophisticated and quite complicated, and quite well constructed actually. But the important thing is it doesn't affect everybody. In fact, it affects only one party. Okay? It only affects, it's an attack that was constructed to check what context it was running in, and most of the time it would do nothing. It would actually do its original job. So this is an important thing about this. Okay? There's a version of the stream library, kind of like the stream library that we wrote in class that you folks use. There's a version of the stream library, and then there's a new version of the stream library that does all of the stuff that the old version did. It still works normally. It still does streams, right? Which means if it didn't, you'd notice it. You'd be like, it's not even giving me streams anymore. What's going on? But as long as it does what it's supposed to do, most people don't notice that it might also be doing something else. Now, the something else that it did was it checked which app am I a part of. And for most apps, it didn't do anything else. It just did streams and nothing else. But for this one app called Copay, it was doing something else. Like you haven't heard of Copay, right? I've never used Copay either. Okay, so that's fine. Except, oh shoot, Copay is a secure shared Bitcoin wallet. So now can you guess what it does? Yeah, exactly. So basically, it steals money. So it would check whether you were running Copay, and if you were running Copay, it would find a way to exfiltrate your money, and so it would steal your Bitcoins. That's what that small change to the Stream Package Manager did, Stream Package Application. Okay? And it says so over here, if you read a little more closely, it says the injected code targets the Copay application. When a developer at Copay runs one of their released build scripts, the resulting code is modified before being bundled into the application. The code was designed to harvest account details and private keys from accounts having a balance more than 100 Bitcoin or 1,000 Bitcoin cash. And none of these phrases may mean anything to you, but that phrase is a very, 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 very frightening phrase. Okay? Basically, it means like they own a lot of things. Copay's initial response was that no builds containing this malicious release were released to the public, but now we have confirmation that Copay from malicious release dependent 5.0 to 5.10 actually did contain the code. Okay? Okay. So, that's not good, right? That's quite bad, actually. All right. So that's what Copay is. And several people have posted interesting analyses of these. The technical analyses, I have to teach you more JavaScript than I can possibly teach you to explain how it worked. But what's interesting is also how it happened. Gary Bernard is a person who I think I like a lot. He's a technical speaker and writer and programmer who does some pretty good stuff. And he's very popular, so he points this out. When it first came out, it was actually found on 26 November, so he tweets about it on 26 November, and he says no one knows what the malicious code does yet because they were still in the early days of discovering what happened. Okay? And the way it happened actually is also interesting. The way it happened is there was this package, the stream package that like we've seen literally millions of people are using, but the maintainer had stopped maintaining it because he'd written a stream package and he was done. Right? And in fact, it turned out he wasn't even using it himself. So this guy named Dominic Tarr was no longer using it himself. Somebody came to him and said, do you mind, I mean, it looks like you're not maintaining this. Do you mind if I take over and maintain it for you? And he said yes. And this was the enhancement that the new maintainer provided. Okay? So that's how it even got in. Right? Like Dominic Tarr himself would never have done this, but the way it got into the system is because somebody came up and said, I'll do it for you. Okay? And so he says, so what does Gary say? This is the original maintainer's fault. So there are basically two camps. So lots of people have started to analyze it. Of course, nothing the internet likes more than analyzing security faults. So there are two camps in the analysis. He says, some people say it's the original maintainer's fault for transferring ownership to somebody they don't know and trust, right? Some random dude comes up to you and says, can I take over your code base, right? Now, the other camp is like, look, ownership transfer is just ownership transfer. In fact, one of the points Dominic Tarr made is, I transferred ownership because it's not like anybody was paying me for any of this. I wasn't getting anything out of this. It's just like a thankless job maintaining code for random people. It's code I'm not even using, so yeah, somebody wants to take it, sure, I'll give it away. Right? The other view is ownership transfer, it's fine. It's your job to vet the code you run, right? This is part of open source. Open source means you can see all of the code. And if you're building a secure system, you should make sure that you read the code you're running rather than just randomly pulling code off the internet. Now, Gary points out, option 2 of vetting all the dependencies is obviously impossible. Last I looked, a new Create React app had about 1,000 dependencies, all moving fast and breaking things. Okay? Now, most of you have probably not had the experience of working with NPM. I have had a little bit of experience with it, and it's a little hard. I want to give you a little sort of a scientific visualization of what it means to pull in an NPM package, right? You install one package. I want to give you a feel of what it looks like. It's this. This is roughly what happens. Okay? You ask for one little thing, and it turns out that one little thing depends on about 1,000 other little things, and next thing you know, whoosh! So what are you going to audit in this? What are you going to look at? What hope do you have of being able to, quote unquote, make sure about anything? Right? That's the point he's trying to say. Vet all the dependencies is obviously impossible. You try to bring in one package, you brought in 1,000 new packages. Now, option 1, a chain of trust between package authors, seems culturally untenable given all the reactions in that thread, which is basically like everybody's yelling at the author, and all these other authors say like, you don't understand, it's a nightmare to maintain any software because all people do is complain at you and then get angry at you. So, then there's the third option, don't decompose your application's dependency graph into thousands of packages. People who argue that position were dismissed as, to paraphrase heavily, old and slow. That ship has sailed and now we're here. Okay? This is the state of the art of software maintenance in 2018. This is the world you're all going out into. Okay? And it turns out it's actually, this package is used much more widely than you think. VS Code is Microsoft Visual Studio, so maybe one of the most widely used programming environments in the world. VS Code was also hit by it. So there's some people like, do you know why VS Code say we have uninstalled Tomoki 207 PDF was reported to be problematic? It's because it had a dependency on event stream. So VS Code mysteriously said, we're just taking some things away, sorry. But it meant that this random dude developer managed to get their potentially malicious code into VS Code. Now, fortunately, they were not looking to affect VS Code. They were only looking to affect Copay. But if you can affect VS Code, you could, in principle, also start inserting code into people who are writing code in that editor. Right? So you are writing your program in Visual Studio, right? You write your innocent program, but because I control the editor, the program that I actually compile may not be the program that you wrote, right? I mean, just imagine, every time you click the run button in Pirate, you're hoping that the thing the compiler gets is actually the code that you wrote. Thanks for giving us your Google credentials. Yeah, so good. I think some of you appreciate the severity of what I said and some of you don't. But there's a weird thing going on here, right? Compiler writers have way more power than you think, because they give you this illusion that the program you run is the program that you wrote. In fact, when you type that at the Pirate interaction window, do you know what actually happens? That program, if you let's say that, right? That comes back and says 7, right? So clearly that ran and produced 7. Well, your browser doesn't run Pirate, your browser runs JavaScript. So this program had to get compiled into a JavaScript program that then ran and produced 7. Okay? So there's an eval step going on to turn. First, this has to get turned. So the program that reads input over here is the Pirate compiler. It reads your input and it translates. In fact, for example, it makes sure that it doesn't use JavaScript plus, because JavaScript plus is weird in all sorts of ways. So it actually uses a sane version of plus. So it compiles all of this. It compiles 3 into something, plus into something, 4 into something. And then that program is then compiled into JavaScript. That JavaScript is then run. But where did that program come from? Because that program that's reading that input has to be in what?
JavaScript.
It has to be in JavaScript, right? Because I said the only thing the browser runs is JavaScript. So the Pirate compiler has to be written in JavaScript. Well, we don't like programming in JavaScript. It's a terrible language for programming. I mean, we actually do like JavaScript, but it's a terrible language for writing a compiler. So in fact, the Pirate compiler is written in Pirate. And what's up with that? So what actually happens is the Pirate compiler, remember, what's the Pirate compiler? The Pirate compiler is a program that takes Pirate code and produces JavaScript code, right? It takes, not strings, but think like, it actually takes a string in and produces JavaScript, not quite strings, but imagine strings out, right? That's what it is. So the Pirate compiler is a Pirate program. So the Pirate compiler is fed to the Pirate compiler to get a JavaScript program that does the same thing. So that now is a JavaScript program that implements a Pirate compiler. So it's a JavaScript program that takes Pirate programs and produces JavaScript programs. So in fact, every time you load Pirate, part of the reason Bonnie spins is because it is compiling the Pirate compiler through the Pirate compiler to produce the JavaScript, to have something that's available in JavaScript over here, so that when you then write this expression, it goes into the JavaScript implementation of the Pirate compiler, which then compiles and runs and produces this answer. But that whole thing is the Pirate compiler in, yeah?
So if you wrote the compiler in Pirate, when in the process did you actually write the compiler?
Yeah. So there was an initial bootstrapping process. So if you go look at the Pirate GitHub repo, it's a little disturbing. There's actually a 6-step bootstrapping process. If you go down here, installing and running Pirate. So you can see it's got all these phases over here. So it's a self-hosted compiler, which means building the compiler requires some thought. Here's a brief overview. Phase alone is a standalone JavaScript file. Phase 2 is a setup to be populated. Phase B is populate the built versions. Then it has to build itself from the built versions, and all of that has to happen to get a new version. So if you make a small change in the language, you have to go through all of these steps to get a new version of it. And somewhere in the middle, it's a little bit like making yogurt. Okay? How do you make yogurt? You need yogurt to make yogurt. Right? So the same way, you need an initial version of a Pirate to JavaScript compiler in JavaScript to be able to make the next one. So we used the previous compiler to make the next compiler. Where did the first compiler come from? Lots of hard work somewhere behind the scenes. Yeah. So this is the problem, right? All of this is happening every time, like something like that complicated is happening every time you load up CPO. right? So compilers are a terrible place to have this kind of dependency injected, because this could have also said my copay or my Microsoft Visual Studio, and if I'm Microsoft Visual Studio, let me just inject the copay checking code into all generated code. In fact, I could do it for all Bitcoin code. Yeah.
Does that mean that node can run in a PDF? Like, why was it a PDF that was reading?
It's complicated. I don't want to get in. You should go look it up. I would spend the rest of class if you derail me that way, so I don't want to do that. Yeah.
How do you prevent JavaScript injections into Pirate?
Because I'll get to it by the end of class. Yeah.
How did they insert this code into Visual Studio?
They didn't. Visual Studio depends on a stream package. They inserted it into the stream package and it just flowed upstream, so to speak, to end up inside Visual Studio.
But if someone had already downloaded Visual Studio, how did it get into their computer?
This is Visual Studio Code. It's the web version. It's the JavaScript version. That's how. Okay? Okay. And, as you can see, they said, yeah, yesterday's event stream NPM breach has been cleaned from VS Code, but if you launch it, you have to go and reset up, right? So it actually did make it all the way into Visual Studio Code. Okay? And one more like this. Now, the flip side of it is, my builds are failing because event stream has been deleted from the NPM. So it's all like deleting it also causes software to break because this poor dude can't write code anymore, right? And they had to go recompile all their dependencies. So it's pretty bad. Okay? All right. So that's the problem. You get a sense now of the problem. Somebody managed to get hold of this package. They inserted something that does something malicious, and everything that depended on the package is now being affected by this one bit of malicious code, which is very cleverly constructed. So now let's see what the internet has to say about how to solve this problem. Okay? So, on NPM event stream, everything is right, but those things that are used in production, we're trusting a bit too much the NPM ecosystem. Okay, well, that's pretty clear. All right, not very insightful. But there are more concrete things, right? Dear Node.js community, fix this or you'll have many more of these. Left pad is a different kind of bug. Here's what you should do. Set yourself an upper sane limit for the number of dependencies. We should start with that. Okay. And then what happens when you have more than 100 dependencies? Well, it's Twitter, right? It's not his problem to actually solve problems. It's just to talk about it. So it's very simple math, by the way, apparently. Okay. So maybe that's not the best thought out solution by Hanno over here, who's a freelance journalist. Okay. But now we have a LinkedIn page with a cool icon, right? Okay, so that's got to be serious. 3 takeaways. As the world continues to build software at a breakneck pace, we need to keep vigilant, blah, 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 blah. The software supply chain, how could this happen? You need attribution and trust. You need DevOps hygiene. And moving forward, this person's thing is that Daniel Riedel is into software bills of material. Okay? So basically, what files went into a build chain. I don't know why that actually solves any problem. The concept is very straightforward, which of course is why it's not going to make any difference. But at least it's got 3 points to make. Okay? Maybe JavaScript needs consortiums of people maintaining packages so developers don't get burned out. Or for Python, blah, 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 blah. Okay? So we need consortiums of people to solve this problem. Because we already have all these unpaid volunteers who are not burning out. So we'll have consortiums of unpaid volunteers to check. It's something like that, apparently. Okay, so JC, JC's got his solution. Thank you. Lots of blaming and defending the original author that gave up a popular package and saying good luck using NPM without its code. The real issue is the NPM method of operating. No solution but to abandon it. Okay, well, that solves everything. Okay, so now we've come full circle here. Okay. None of these is a particularly promising solution, is it? Nobody seems to have a clue what to do. Okay, now I want to tell you about another very interesting article. This one's really fun. Okay? So this article is called "I'm Harvesting Credit Card Numbers and Passwords from Your Site, and Here's How." Okay? It's worth reading. If you're interested in this sort of stuff, go look at it. It's at Hacker Noon, and it's David Gilbertson. You can look it up from the video. But what he says is, look, here's what I do. I have a form where you take in a credit card number, right? You have a form for credit card numbers. It's gonna do some stuff, okay? And essentially what he points out is, how am I going to steal it? I'm not going to come and attack your page directly, right? I'm going to create a node package, right? People love pretty colors. It's what separates us from dogs. So I wrote a package that lets you log to the console in any color. So now it's just a package for adding colors. Who could object to adding colors? So I was excited at this point, And I made several pull requests to lots of other packages to try to convince them to use it. And several of them said, yeah, and of course the pull request just says, oh, I fixed some issue, and by the way, I also added some logging. Well, okay, fixed an issue and added the logging. That sounds like a good idea. Campaign's been a big success. Now I'm directly into 23 packages. Now, I noticed the network requests going out. Well, would you? I can actually do the following thing in JavaScript. You can basically check whether somebody has the console open. And if the console is open, don't transmit any data. When the console is closed, you transmit the data. So the very tool you use to check whether the data is being transmitted doesn't check it. So he calls it like the Heisenberg maneuver, right? So at the point of observation, you turn it off. Okay. Our penetration tools would do it. Oh, well, depends on what time you run the tools. Okay. I see your source in GitHub. Your innocence warms my heart. Okay. I read the minified source of all the code and node modules. Like, all right, now you're just making up objections, right? So, et cetera, et cetera, et cetera, right? So he points out that this is actually a really good attack vector on anything. This isn't specific to Node. You have Python libraries, you have R libraries, you have bracket libraries. All of them are susceptible to these kinds of attack vectors. Okay? Just as we have the software culture where we bring in volumes of other people's code and we get to benefit from it, right? I mean, building a page like this, right? Somebody had to figure out how to make that hand icon count something, and how do we make like that button actually listen to something, and the follow button and the search button. All of that is work. And we get all these packages that seem to do it for us, but we don't know what they actually do. We don't know what they actually do. And the more we virtualize our infrastructure, the more we put control systems on the internet, the more we use electronic cash for payments, the more and more vulnerable we get. Okay? Okay, so let me now show you a few people who had a slightly different point of view on this. Okay? What you don't know, that I happen to know, is they're actually all each other's friends, so it's only one point of view, but it'll make it look like different people's points of view. Okay? So Dominic Tarr, by the way, is the original person who wrote the Stream Package Manager, a Stream Package system, and then stopped maintaining it and moved off. Okay? So he's in some sense, you know, he's got some authority here in this situation. This is the point that not enough people are getting. It's that the way the risks combine. Each module introduces a small risk that the maintainer does something stupid in the current design of how most package managers and languages work. Compromise of any module compromises the whole system. Right? All it took was one tiny module to be compromised, and it had this global effect. That's an interesting thought. Okay? Zuko, who's a very sharp guy, says, it kind of depresses me how everyone is responding to the NPM dependency injection, that's the technical name for what happened, by talking about reusing code less of vetting authors more, which is kind of the same thing, instead of talking about making code reuse safe. That's what we actually want. We want to be able to reuse as much code as we want, but we want the act of reusing code to be safe. Okay? And he makes a mention about a company called Agoric, which is in this space. Right? Mike Samuel says, a module that defines stream mapping operators, listen carefully now, we have an insight. A module that defines stream mapping operators doesn't need access to the file system, access to the network, to globally change how modules are combined, or to link against copay. Why is it that a stream library, we wrote stream libraries, right? I wrote a stream library for you in class. You effectively wrote or rewrote or used a stream library in your continued fraction homework. What business did any of that code have writing to disk, talking to the network, and stealing bitcoins? It wasn't any of its business, right? That's what he's trying to say. That's a technical insight there. I'll get back to this now. Okay? So what I want to do now is switch to talking about something else that will turn out to be related. You've all now done a lab on the Unix shell, right? So you're now familiar with a few shell commands. So you have a thing like ls, which lists the files in your directory and so on. Okay? Let me ask you a question actually. What is the most dangerous program on your computer? Most of you have a laptop, I presume, so what is the most dangerous program on your laptop? Yeah.
RM.
RM, because it deletes files?
Yeah.
Maybe.
Sudo?
Sorry?
Sudo?
Sudo? Oh, sudo because it changes privileges? Okay.
Chrome?
Chrome? Okay, why Chrome?
Because you can download anything.
Ah, you can download anything. Very good. Okay, yeah.
Because the malware checker, because if it's wrong, then
Ah, the malware checker because it creates a sense of trust, and so if it says everything's good, you might think it's good, right? Okay. Anything else? So I saw a hand up there somewhere.
I was just gonna say Chrome.
Chrome. Yeah.
What about LF?
LS? Why?
Because if you can't find any files on your system, then
Okay. I would argue you're all thinking about this problem incorrectly. Okay? I would argue something far more dangerous might be on your computer. Solitaire. You have like a solitaire or a chess program or something on there. If I were an attacker, I'm not going to go after Chrome. I'm not even going to go after the malware checker. I'm going to go after your chess program. Why? What does your chess program do? It consumes a lot of cycles. I can hide all kinds of bad activity behind the cycles it's computing, and you're just going to think, oh, my fan is spinning. I must be thinking really hard about my chess moves, right? Slow it down a little bit and spin the fan up, and you would think, wow, this is some really hyper clever chess program. In fact, here's what I would do. I would make your chess program be really bad and take a long time. Why? Why would I make it take a long time and play bad moves? Because it would make you feel superior. You'd be like, what an idiot. This dumbo here seems to take seconds to make simple moves, and they aren't even very good moves, and you will bask in that sense of superiority and not think about the other things that I'm doing behind the scenes. When you install a program, and don't feel superior about this just because you run like, Alpine Linux or some nonsense like that, okay? When you install a program on Windows, on OS X, or Mac OS, as it's called, or Linux, that program has all of the same privileges that you do. If you can write to the file system, that program can write to the file system. If you can speak on the network, that program can speak on the network. If you can go and change some system configuration, that program can change the system configuration. Programs like sudo are actually very safe because you explicitly granted it privilege. You made a conscious choice. The problem is your Sudoku program, your chess program, your solitaire program, they could be doing all of the malicious things you're thinking about, like downloading a file. With Chrome, when you download a file, it does like a nice whoosh and puts a little thing at the bottom. Your chess program could be downloading files. Does it do that? Does it like, while in the middle of your chess game, does it go whoosh and put a thing at the bottom? How do you know it's not downloading files? You have no clue. You have no idea what's happening with that program. Okay? The way a good attacker works is they always feint, right? That's why this attacker didn't go and put it inside the crypto library. They put it inside the stream library. The crypto library is too obvious a place. Everyone's looking there. The stream library, it's like streams, dude. Right? Nobody's looking at the stream library for crypto attacks. So there's a program called CAT. Stands for concatenate. So essentially if I say cat AB, okay? What that does is it basically copies. Think of it as copy. Actually, well, let's do CP instead. Cat is okay. So here's CP. Okay, CP means copy files. So if I say CPAB, that means look for a file named A and copy it into a file named B. Okay, that's what it does. There's actually another way to write CP. Okay? I could have written CP less than A, greater than B. I'm leaving enough spaces so you don't get confused by the symbols here. Do you remember, did the version of the notes that the lab notes on Shell have the less than greater than notation? You did, right? Yeah? Anyone remember this? Okay, let me tell you what less than greater than means. Less than means read from file A, greater than means write to file B. Okay? Now, hopefully you're thinking, how is this any different? Doesn't this mean read from file A and write to file B? Right? All I've done is, I said this is the from position, this is the to position, and here I put like a less than and I put a greater than. They're actually completely different. Completely, totally different. This little change here represents a complete change in security paradigm. Here's why. What happens when you do this is that command means tell the shell program, right? I'll write percentage if that's more familiar, right? There's my shell program that I'm running against, okay? Tell the shell program to go find a file named A, open A, and create a descriptor of A, and give that descriptor a read-only descriptor of A to CP. This means create a space for B, create a write-only descriptor for P, and give the write-only descriptor to CP. Okay? So this version of CP, we'll call it CP prime. CP prime gets two inputs. One of them is a mechanism for reading from some file. The other one is a mechanism for writing to some file. Okay? You can't write to A using that. You can't read from B using that. If you try to write to A with that, it'll say, I'm sorry, that's a read-only thing, you can't write to it. If you try to read from that, it'll say, I'm sorry, that's a write-only thing, you can't read from it. Okay? You have immediately prevented CP prime from being able to write to the wrong thing, being able to read from the wrong thing. And when I say wrong, it may be because it's got a bug, it may be because it's malicious. Okay? There's actually something even more profound happening. What CP prime gets, I told you, it gets this descriptor object, right? That descriptor object is just an anonymous object. It's anonymous. It doesn't know what file on the file system you're referring to. It doesn't know where on the file system, which directory the file is in. It knows nothing about any of those things. Okay? In fact, it doesn't even know the name of the file. It doesn't know that the file was called A and that file was called B. Why could that possibly matter? Why could that possibly matter? The name of a file? Doesn't leak any information, right? Like a file named passwords doesn't reveal anything. A file named private key doesn't reveal anything. ID_SSA.private doesn't reveal anything. File names have a lot of information. Okay? So this way, CP prime has no way of analyzing what the file is about. So this way, CP prime gets only one privilege. Okay? It basically gets the two privileges. The privilege of reading from here, the privilege of writing there. So I'm now giving you a different CP prime where CP prime gets no privileges at all other than those that were explicitly granted to it. And this is a granting action. This is a granting action. This is a read-only granting action. This is a write-only granting action. Guess what other privilege CP prime does not have? Well, it doesn't have any other privileges, right? So one of the things it can't do is talk to the network. How do you know when you copy a file on your file system, how do you know that in the process of copying the file, it's not also making a copy of your file to the NSA? You don't actually know that. right? In fact, that's not what it's actually going to do, right? Because you might have like some network monitor on. What it's actually going to do is maybe fingerprint the file, save a hash of some fingerprint off to somewhere in the file system, which you're not looking at because you're only monitoring for network activity. And maybe at 2 in the morning, it's going to send a ping to the NSA. You have no idea that it's not doing that. This program is designed around a completely different principle. The only privileges it has are privileges that was explicitly given. Because I didn't give it a network privilege, it doesn't even have the ability to talk about the network. The libraries under the language in which it's written doesn't even have a thing called open a network connection, right? This program, the way Unix is structured, the way Windows is structured, the way Linux is structured, it has something called fopen, which is a way of opening file system things. It has a way of opening sockets to talk on the network. It has the ability to do all of those things, and those things are called ambient authority. Okay? Ambient authority is authority that's just present in a primordial state. When the program starts up, it has all of this authority to do all of these things. This is a different paradigm where the ambient authority the program has is nothing. Nothing. The only authority it has is authority that it is explicitly given. Okay? This is a principle of system design called POLA. It stands for the principle of least authority. A program has only as much authority as it needs for doing the task that it was asked to do, and no more. Which means by default it has no authority at all, except maybe the ability to run, right? I mean, that's like the basic authority it needs. It has the ability to like warm up the atmosphere a little bit by running, like using cycles, but that's all it has. Anything related to file systems or disks or networks or SMS messages or accelerometers or locations or any of those things, unless it's granted the authority, it doesn't even have the ability to talk about it. That's a different paradigm of thinking about how to structure systems. You had your hand up.
Yeah, so I was wondering about if you were copying a passwords file, even if you didn't know that it was called passwords, it would still like.
There is a question about what it can do with the content of the file, right? That's a separate question. I'm sort of not addressing it here, but you could imagine actually giving it an encrypted version of that.
Oh, okay.
Right? So there's actually a weird authority that your Unix file system has, and that your Windows PowerShell has, and that your Linux shell has, and all these things have. When I say CP A and B, the act of saying A means there's a mapping from the name A to some place on your file system where A actually resides. Right? Your file system has like locations, like the file A, named A, sits in some position in your file system. That mapping over here is being done by the Unix shell. The program doesn't get to do that mapping. Here, this program gets just a file name. So it also needs the privilege of being able to do that mapping. It has to be able to do that translation. Which means it can also do things like, oh, let me just see whether there's a file named A tilde somewhere in there too. It can do that, right? It can say, I want to back up this file to something with a tilde at the end of it. Well, that was not a privilege it was given. That was just a privilege it made up. And in fact, if you run different programs, some programs will say .bak for their backup. Some will say tilde for their backup. Some will say, dot backup or something like that. What are those? Those are privileges that they just made up for themselves. They never asked for the privilege to save a backup file. I never gave it the privilege to save a backup file. How was it able to do this? Because to be able to do this mapping, it got the entire file system. Not even the current directory, it got the entire file system. It can go off and look at etc password because it got the entire file system privilege. Now here's why this is particularly pernicious. If this program gets infiltrated or broken into somehow by a virus or something, all of the privileges that CP has, the virus now has. This is how attacks work. They piggyback on the fact that programs don't run with the least authority, they run with maximal authority on all the operating systems that you run on the desktop. They run with maximal authority. And so, because they have maximal authority, if the program gets broken into, the broken in part has all of the authority to do all of the things that you do. It can act as you. So anything that you can do, the program can do. In the principle of least authority, there's a distinction between you, the user, and the program that's running on your behalf. The program that's running on your behalf is explicitly granted privilege, and if it's not granted the privilege, it can't do it. Does that make sense? Questions? You had a question.
Yeah. So does this allow you to do the compartmentalization that people on Twitter were talking about?
So, let's look at that. Yeah, so Kate is also a person who writes about these principles. And so Kate says, it's strange to me that people think the lesson from event stream attack is about an NPM package maintenance. It seems like the real lesson is that we have crypto wallets that aren't using the principle of least authority. Right? Why is it that a streaming package had the authority to read or write anything related to crypto communications? This is a quote from a famous paper. It's a very, very useful quote. The mistake is asking how can we prevent attacks. We're never going to prevent attacks. Okay? When we should be asking, how can we limit the damage that can be done when an attack succeeds? The former assumes infallibility. The latter recognizes that building systems is a human process. If every component in your system ran with the least amount of privilege, then even if somebody broke in, they can only use the privileges that that component has. They can't automatically get any other privileges. That's what it's trying to say. Okay? You can read more about this elsewhere. There's actually a few libraries that are very good for this. So in JavaScript, so this is something that Pirate relies on. And in fact, we've contributed some stuff to this too. We found some bugs in this, haha. Okay, so this is called Secure ECMAScript. And Secure ECMAScript is just a fancy way of saying JavaScript. It's like making JavaScript sound like a disease, but that's really what it is. So Secure ECMAScript is a frozen environment for running JavaScript mode programs with no ambient authority in their global scope. So they don't get any ambient authority. The only authority they get is authority that's explicitly granted through the use of objects. You give it an object, the object, so for example here, if I were writing CP entirely in my programming language, I would give it an object. This object would have only a read method. This object would have only a write method. So if you try to write to this or read from that, it would fail. Right? So you pass objects that have limited amounts of privilege, and you lock down all of the ambient authority so that they don't have any, and then the only way any part of the system gets authority is by getting an object that provides it that authority. And there's a whole mechanism that's been designed around this. There's also a very cool system called Shill that I like. Shill is a language that's built inside Racket, so it's # Shill. And I mean, it doesn't look like Racket, it looks like all semicolons and braces and stuff. But what it is a shell scripting programming language. So just like you wrote shell commands, this is a language for writing shell commands, but the critical thing is you get to explicitly say what kinds of privileges you're providing, and because it's a file system, it's even whether they're recursive. So what kinds of, you're doing a copy, the copy is from certain things, it's to certain things, and you say what the types of things are, and you list all of the privileges in the signature of the function, and those are the only privileges that you get. Right? Everything is done by explicit granting. And because there's this mediation through an object, you can also provide fake objects. If I don't trust you, I can provide you a fake object. I can say, you want a file system? Sure, here's a file system. But it's actually a completely fake file system. It's all stored in memory and nothing actually gets written to disk. You don't know, because you don't have the ability to check that mapping. All you get is some anonymous thing that says, a file system. You can't tell whether I trust you or not. This is why we briefly alluded to this, why function equality doesn't work in Pirate. Because if I let you do pointer equality on functions, you could tell whether I gave you the right function or whether I gave you a wrapped function, and then you would know whether I'm trusting you or not, and then when I'm not trusting you, you could do evil things and do other things at other times. right? Exactly that business about don't do something when somebody is looking. I don't want you to know whether I'm trusting you or not. That's why we don't give you that ability in Pirate. Right? So that's another thing that object equality languages do. They take away equality checking, pointer equality checking on functions, on objects, because then you can no longer tell whether you're getting the mediated thing or not. So I can mediate, I can check what you're doing, I can cut off your access. There's a whole family of interesting programming patterns you get once you work in principle of least authority languages. You use objects as a way of providing privilege, and then the objects can do things like monitor. So I can even be writing your stuff to the file system, but I can be checking what you're writing. And if I see that what you're writing is content I didn't want you to have, I'd be like, aha, you must have there must be something going on here, and I can then quietly virtualize away your accesses, right? These are all things you can do if you work in a principle of least authority language. You can't do any of it in conventional programming languages. None of it. You can do all of these things if you had an operating system that respected principle of least authority. You can't do any of it in conventional operating systems. So when you go off into computer science, you run into things like security problems, just be aware that there's actually a lot of wisdom out there about how to do things better. Part of the problem is getting people to move from our current designs to new designs, right? We built systems to be maximally insecure. The internet, operating systems, programming languages, all of these things were built to be maximally insecure. And now we live in a world where there's lots of evil going on. And we're like, oh my God, what can we do? Maybe we should get groups of volunteers. Like, no. So there is a lot we know about how to architect systems better and how to architect systems more securely. One of the things I hope you'll do in the course of your computer science education is to learn more about those things. But just keep in mind when somebody says, oh, we can't do anything, whenever somebody says we can't do anything, it's always relative to a particular architectural choice. We can't do anything on Linux, today's Linux. Yeah, you're right. But you know there's something called secure Linux, SE Linux. SE Linux is not quite an OCAP system, but it has a different notion of security, but it gives you a much more secure Linux environment, right? Why don't people use secure Linux? I don't know. Some people do, some people don't. But saying that there's nothing better we can do is always a position relative to what we have and the assumption that nothing can change. We got a huge improvement 10 years ago. You know what happened 10 years ago? We got new operating systems for phones and then for tablets. So the security model of iOS and of Android is vastly different from the security model of your desktop operating system. On Android or on iOS, on iOS it does it dynamically, on Android you can also do it statically. On Android, you can't get access to the network till I give you network access, right? You can actually go into an app and you can configure the privileges of an app and you can say turn off network access for this app, right? It doesn't need any of these things, right? You can do that. That's a checkbox version. It's not quite as powerful as this, but at least it gives the user some control back, right? This is why I'm very excited about Chromebooks. I'm very excited about Android and Chrome as a new operating system for the desktop, because we get a more secure operating system for free and we can abandon some of our legacy systems. So if you're thinking about operating systems, you're thinking about security, you think about programming languages, you think about any of these things, there's a ton we know and there's a ton more we can do. Don't let people make you think like, oh man, it all sucks, there's nothing you can do about it. There's a lot you can do about it. You gotta be willing to make some sacrifices though. All right? Good. So I hope I've left you completely depressed. On Friday we'll do course evals and I'll take any final questions. Okay? See ya.